Ever pondered what makes a self-driving car navigate a busy intersection with ease? Or how a spam filter accurately sifts through thousands of emails? The answer to these questions lies in a powerful concept in machine learning called Bayesian networks. Bayesian networks, also known as belief networks, are a type of probabilistic graphical model that uses a directed acyclic graph, DAG, to represent a set of variables and their conditional dependencies. But wait, don't get caught up in the jargon just yet. Break it down, and it's much simpler than it sounds. Scene script. Imagine a group of friends, each with their distinct personalities and habits. Now, if we were to predict how one friend might behave at a party, we would consider factors like their mood, their relationship with the host, and perhaps even what they had for lunch. Each of these variables influences the final outcome in some way. This is the basic idea behind a Bayesian network. It's a statistical model that represents a set of variables and their conditional dependencies using a directed acyclic graph. So what's the deal with this directed acyclic graph? Picture a flow chart where each box is a variable and the arrows show how one variable influences another. The directed part means the influence only goes one way, and acyclic means you can't loop back to a box once you've left it. Output. In machine learning, Bayesian networks are used to model uncertain knowledge and reasoning under uncertainty. They offer a compact, flexible, and interpretable means of defining joint probability distributions. They can represent causal relationships, making them a powerful tool for understanding complex systems and predicting outcomes. Now remember our friend at the party? With a Bayesian network, we could model the probability of them dancing, given their mood, relationship with the host, and what they had for lunch. This model could then be used to predict their behavior at future parties, given similar variables. This is the essence of Bayesian networks in machine learning, leveraging the power of probability and statistical independence to predict outcomes in complex systems. It's a fundamental concept that powers many of the technologies we interact with daily, from search engines to recommendation systems, and yes, even self-driving cars. To sum up, Bayesian networks are all about understanding the world in terms of probability and dependencies. They model a set of variables and their conditional dependencies using a directed acyclic graph. They are used in machine learning to model uncertain knowledge and reasoning under uncertainty, and they can represent causal relationships. These networks are powerful tools for understanding complex systems and predicting outcomes. So, the next time a self-driving car navigates a busy intersection or a spam filter accurately sifts through your emails, remember, there's a Bayesian network working behind the scenes, making sense of complexity, one probability at a time.